Hello everyone. Welcome to my new video. In this video, I'm going to teach you about TouchGFX GUI and hardware interaction. We'll create a simple GUI app on an STM32 board with two features. A GUI toggle button to control an LED. An external push button to toggle a UI bulb on the screen. Let's start. Open TouchGFX and create a new project. Select your board. For this demo, I use the STM32F429 Discovery board. Choose a project directory. Give your project a name. And then create the project. You can also set the display orientation. Next, let's create the screen. For this project, I'll only use one screen. Add a background image by selecting the image widget, then choosing an image source. I'll use an image from the TouchGFX stock library. And I'll select one that matches the display's pixel size. Now, add a toggle button to control the LED. Then, select an image for the toggle button from the stock images as well. We can assign different images for the on and off states. I'll use the default selections for now. You can also add custom images as well. Give the unique name for the toggle button. Next, to toggle the display bulb using the external push button, let's add a new image widget. This image will represent the bulb off condition. I'll select the image and adjust its width and height. Then, I'll set the name property to image bulb off. Now, we'll do the same for the bulb on condition. Add another image widget and select the same base image. Resize it as before, but this time, change the color to yellow to indicate the bulb is on. Move this image to be on top of the off image, and you uncheck the visible checkbox. This way, by default, the off image will be visible when the screen starts. Next, we need to add an interaction for the toggle button. To do this, go to the Interactions section and add a new interaction. Set the trigger to button is clicked. Then select the button you added earlier. For the action, choose Call a new virtual function. And give a name for the virtual function. Now, the simple screen setup is complete. Finally, click Generate Code to generate the project files. Then, open the project folder location. Click on the .ioc file to open CubeMX. Now, we need to configure the GPIO pins. On this development board, pins 13 and 14 are connected to the LEDs. So, set those pins as GPIO output. Pin 0 is connected to the external push button. Set this pin to extended interrupt mode. Next, go to the GPIO configuration. For pins 13 and 14, set the maximum output speed to high. For pin 0, set the GPIO mode to external event mode with falling edge trigger detection. After that, open the NVIC interrupt table and enable the interrupt for the external input. Then, go to the middleware section. You'll see that Xcube TouchGFX is already selected, and the graphics application is properly configured. In this project, we don't need to change the clock configuration. Now, generate the code. Next, copy the project directory and open CubeIDE. Go to File, Open Projects from File System. Set the import source to your project location. You'll see the project detected automatically, then click Finish. You might see some warnings in the Problems tab. Right-click the warnings and apply the quick fix. Personally, I like coding in VS Code. So I'll open VS Code inside the project folder. Now, open the main.c file. You can see the GPIO pins are correctly set as outputs. Let's start coding the interaction between the GUI and hardware. Inside the TouchGFX folder, under SRC, you'll find folders for Screen 1 and Model. Let's quickly talk about the file structure. TouchGFX uses the Model View Presenter (MVP) design pattern. You can find more information in the documentation, but I'll explain it with the code here. You can see auto-generated files for Model, View, and Presenter. Screen 1 View represents the actual GUI elements. If we look inside Screen 1 View base, you'll find the function linked to the interaction we set earlier in TouchGFX Designer. Let's override this function in the View class. Inside this function, we need to toggle the GPIO pins 13 and 14. To do that, we need to call the presenter from the view. In the presenter class, create a new function called LED toggle. Now, in the View class, call this new function when the user clicks the UI toggle button. Then move back to the presenter function. From the presenter, we need to update the model. So, open the model class and add a new function for LED toggle. To summarize, from the Views function, we call the presenter's LED toggle function. From the presenter, we call the model's LED toggle function. Don't forget to call model function from the presenter. Now, inside the model, we need to interact with the hardware. Let's create a C function to toggle the LEDs. Open the main.c file and define a new function that toggles pins 13 and 14. Then, move back to the model.cpp file and link the C function we created in main.c to the model class. Call that function from LED toggle function of model class. Now, when the toggle button is clicked on the UI, the code will flow from view to presenter to model to hardware. Save all the files. Now, switch back to CubeIDE. First, build the project. There's a build error, looks like I forgot to add a semicolon. Let's correct that and build again. Now, the build finishes successfully with no errors. Let's download the code to the board and start debugging. The program downloads successfully. Now let's check the output. You can see the UI is loaded. And when I click the toggle button, the LEDs toggle correctly. This shows that our UI interaction is properly connected to the hardware. Next, we'll set up the interaction from the hardware input to the UI. Let's begin. Let's first create the external event. First, create an integer variable called imgbulb and set its initial value to 0. Then, override the HUL GPIO external interrupt callback function. Inside this function, if the external interrupt pin is GPIO pin 0, set the IMG bulb variable to 1. Next, open the model.cpp file and link the IMG bulb variable. Now, inside the model tick function, we need to check if IMG bulb is equal to 1. If it's 1, first reset it back to 0. Then call the view to update the UI. Here, we are calling IMG bulb toggle through the model listener. Now, let's create the IMG bulb toggle function. First, in the model listener class, add a new virtual function called IMG bulb toggle. Then, override this function inside the presenter, because the presenter inherits from the model listener. Now, in the view, create a new function called IMG bulb toggle. Inside this function, if the IMG bulb off image is visible, set its visibility to false, and set IMG bulb on visibility to true. Otherwise, do the reverse. After updating the visibility, don't forget to invalidate both objects to refresh the UI. Now, let's build the project. The build is finished successfully with no errors. Let's download the project to the board. You can see that when the push button is clicked, the UI updates correctly. The bulb image toggles between on and off. In this video, we created a simple TouchGFX GUI on the STM32F429 Discovery board. We added a toggle button to control the LEDs from the UI, and used an external push button to update the UI bulb image. We also learned how to connect the TouchGFX model view presenter structure with hardware events. If you found this video helpful, don't forget to like and subscribe for more STM32 and TouchGFX tutorials. See you in the next video.